Hi there, this is Mr. Robinson, and thank you for watching the Algebra 1-2 Chapter 4 review. Now, this chapter review will cover a lot of things, honestly, a lot of things that are in Chapters 1 and 2. But also chapter... Okay, well, so this is from homework number 23. And homework number 23 is Chapter 4 Closure. And I'm going to be honest, not everything on this thing is what's going to be on the test. One big thing is missing in this thing, and it is the equal values method. And so what I'm going to do is, I'll walk and talk through the very last set of problems, the graphs, and I'm going to use that to help you out with the equal values method, if y'all don't mind. And the good news about this, though, is that it does help you for your final. It does help you for your benchmarks, and in all honesty, you need to solve these problems using combining like terms and solving equations and stuff, so it's no biggie. It does help you. I will try and run this shorter than 15 minutes like the one I did last time. But that does require that I do a little less teaching as I talk through it. Hopefully you can follow through the problems, and that'll be good enough. But in order to make that happen, I need to get started, so here we go. Okay, simplify the following expressions if possible. Now by that they mean let's combine like terms. So I'm going to go slowly through part A, and I'll speed up as I go through. Just make sure you pay close attention to what I do. I'm going to take this x right here. I'm going to box it. Anything else that ends with an x, and only an x, not an x squared, I will also box. And I'll also box the sign that's in front of it. So that's a plus 4x, not this, and this here, this minus 2x. Okay? And then after that, I'll go ahead and take the 3x squared, and I'll circle that. I want to get a different shape for it, because it's important that I recognize that these are different terms, and they are not alike. And then the negative 3, because I'm running out of shapes, I'll go ahead and underline that one right there. So I'm going to rank this from ascending to descending order. This positive 3x squared I'll write first. That's 3x squared. And then I have x, then plus 4x, minus 2x. Notice how all three of those are like terms. I want to bunch them together so I know exactly where they are. In fact, I want to write a 1 as a coefficient in front of here to know exactly what I have. And then there's a negative 3 that sits on the outside. So I've taken care of all 5 terms. They're all written just in a different order. So I have 3x squared. That doesn't combine with anything. 1x and 4x and negative 2x all combine. So that's 1 plus 4, which is 5. 5 minus 2, which is 3. It's positive 3x. And then there's a negative 3 sitting on the outside right there, and that's minus 3. We've got a lot of 3's there going. Okay, so that's 3x squared plus 3x minus 3 combined. B, let's go and do the same thing. Now, these are supposed to be squareds. Sorry about that. I typed this out, so, obviously there will be some issues here and there. I hope not too many typos. This is 2x. Let's box that and box anything else that has that. Now, keep in mind, it doesn't matter what shape you use. The fact is the shape should be the same. It shows that you're grouping things together. Some people cross these things out as they go. Some people are like, okay, I know I've written that one down. I'm going to go ahead and do that. Oh, I didn't box this 3x, you see? You want to make sure you have everything taken care of. And a negative 9. So I have 4y squared minus 6y squared. 4 minus 6 is negative 2. It's negative 2y squared. Notice how I'm saving not doing this step. Like I said, I would speed it up. 2x minus x is x. X plus 3x is 4x. That's positive 4x. Then you have the minus 9. And that's all that is. And that's simplified to that. Doesn't matter which order you write it in. Absolutely not. Just make sure that these things are there. This is a negative 2 for y squared, a positive 4 in front of the x, and a negative in front of the 9. Or negative 9 as a constant. C, let's use a different color for sake of variety. 3x squared looks like it sits alone. I'll try a different method for those who do this. I'll cross this one out and write 3x squared. 10y can't combine with anything else either. Let's cross that one out. That becomes 10y. Negative 2y squared, no y squareds there. Cross that out. That's a negative 2y squared. Looks like nothing combines here. I'm sorry for that. But hey, it's just another method in minus 14. Nothing can combine. This is your final answer. Don't try and combine things that cannot. You're adding things, and they can only combine if they end with the exact same thing. That's the letters and the degree of it as well. X squared does not combine with x. Okay, and finally, now, these xy's don't end the same as the y squareds do, so those won't combine either. But the xy's combine with each other, the y squareds combine with each other, and the constants combine with each other. Y squared minus y squared is actually 0. Those cancel out. Those are gone. They cancel each other out. 3xy minus 4xy. 3 minus 4 is negative 1, so that's negative 1xy, or you could just write negative xy. Let's cross those out. 20 plus 10 is 30. So this is negative xy plus 30, or 30 minus xy. Finally, evaluate the expressions in parts a and b above when x equals 5 and y equals 2. So what you could do, and in fact I did this in the last chapter, the last chapter review video, so I'm not going to do it twice, but what I did was I plugged in some numbers for x and y, or for whatever things they were, in the original equation and the simplified equation. And the bottom line is they should both be the exact same. So I should get the same answer. That's the whole point of simplifying something. I'm not changing the number, I'm just changing the way that it looks. That being said, I'm going to go ahead and choose x equals 5, y equals negative 2 into my simplified versions. They're simplified for a reason. They should be easier to work with. So I'll go ahead and plug in 5 for x here. I get 3 times 5 squared plus 3 times 5 minus 3. That gives you, notice, I'm not going to do 3 times 5 first to get 15. Order of operations tells me that I square a number before I multiply by 3. So 5 squared is 25, so I get 3 times 25, plus this is 3 times 5, that's 15, minus 3. 3 times 25 is 75, plus 15, minus 3. And then I get 75 plus 15 is 90. 90 minus 3 is 87. Okay, moving on. Part B. Let's go ahead and plug in negative 2 for y and 5 for x. All right, some important concepts here. Same thing. I should square the negative 2 before I multiply by negative 2. Now, negative 2 squared, negative 2 quantity squared is negative 2 times negative 2. That's positive 4. So outside will be a negative 2 times positive 4 inside, because negative 2 quantity squared is 4. 4 times 5 is 20, and then minus 9. So we get negative 8 plus 20 minus 9. All right, time to work on some stuff here. You got to make sure that you that you don't screw up the way you put this. This is not negative 28. Negative 8 plus 20. Here's for the, I have a strategic algebra support class. Here's something I might say to them. Either this is the same as 20 minus 8, which it is. That's 12. Or try it this way if you want to do it in this order. This is negative 8 plus 8 plus 12. 8 plus 12 is 20. Notice how I separated that. Minus 9. Now, why did I do that? Because negative 8 plus 8 is 0. So what's left? Well, that 12's left. Right? This is the important thing about CPM, Common Core, and everything like that is understanding numbers more. And this is one way to do it. You can break it apart like that. Obviously, you guys have a calculator. I just want to make sure that you know. Your benchmark, you don't have a calculator, so it's good to know. 12 minus 9 is 3, so your final answer is 3. Okay. And again, if you did plug in 5 and negative 2 into the original equations that these were, you would have gotten the exact same thing if you did the math right. Just making sure. Okay, number 115, copy and complete the table for the linear pattern below. I'm going to do this 2 different ways because I want to make sure that you understand both of them. One way we can do, first of all, we know that this is linear, which means that this has a constant growth rate. Whatever we add from one y to the next y, we add here, and the same thing as well. This is the easier way. I think you guys know how to do it. It's the quicker way, probably more efficient, and it still gives you your same answers. Thing is, you still need to understand how rules work. And how rules work is they go from x to y. They don't go from y to y. What we're doing here is called a recursive process. We say we need to know how to get to this y by knowing what this y was. That being said, negative 2 to 3, some people might not know that, but you should know 3 to 8, you're adding 5. Therefore, you're adding 5 here. You can double check. Yep, negative 2 plus 3 is 5. So you add 5 the entire way up. Technically, you subtract 5 the entire way down. So let's talk about how to get from one to the next. 8 plus 5 is 13. 13 plus 5 is 18. Negative 2 minus 5, right? We have to subtract 5 to know what that previous number was. That's negative 7. Think about it as adding 5 the other way, though. Negative 7 minus 5 is the opposite of 7 plus 5. Negative 12. Negative 17 and negative 22. Basically adding 5 in a way, if you think about it. Okay. Now I will show you the different way as soon as we get the rule, because I want to have those up for we can talk about growth factor this way, and then we'll do it the other way. What is the y-intercept? Think about y-intercept also as starting value. It's also known as a constant. Basically, it's the number when x equals 0, and we'll talk about that with the rule. Honestly, I wish we did the rule first. I understand why we're doing this because it helps you find the rule. But the y-intercept in this case is when x equals 0, and when x equals 0, y equals -2. So that's that one. The growth factor, that's the number that it grows by every time x goes up 1. So as long as you can confirm that these are going up 1, then you can call that your growth factor of 5 or 5 over 1. If worse comes to worse, and x is growing by 2 or 3 or 7 or -20 or whatever it is, you can always say what the other word for growth factor is, and that is slope. Your slope is your rise over your run, and rise is in terms of y, your change in y. That triangle just means change over your change in x. How much is it going up? How much are the y's growing? 5. Over how much are the x's growing? 1. And it's a constant linear growth rate, and that's very good for you to know, because if these grew by 5 and these grew by 2, your growth rate isn't 5 anymore. It's 5 every time x runs 2. That would be 5 over 2. Of course, that's not the case. These are growing by 1, but you still have to understand that gist. So that's 5 over 1 there. It's -2. Now, 5 over 1 is 5, but I write 5 over 1 to make sure that you understand that rise portion and that run portion. So the rule for this line is y equals 5 times x minus 2. Now that I have that written down, I want to make sure to confirm everything using one different way to do this top portion. And I'm going to do it like this. Okay. First of all, we know that it's linear. Okay, we know it's linear because they say that it's linear, going back to that idea. So if it's linear, that means that they all appear in this form. Y equals some number times x plus some other number, or in this case, minus some other number. Even if those numbers are 0. Remember, they can be 0. Now, we do know that the starting value, the y-intercept, is the same. That's -2. That's because of this guy right here. Okay, this time I'm going to figure out how I get from this x value to this y value. Now, one thing you might do is you might go like, oh, look, you had 2 here. And, oh, no, you know what? That doesn't work here. We have already established what this part is. This is -2. So check this out. Excuse me. The starting value helps you quite dearly. It tells you that if you plug in 0 for x, you'll get -2 for y. That means that this number has to multiply by the x value to make that so. That also means you have to multiply this number by 1 and by 2 and by 3, etc. to get those other numbers. So one thing that we had worked on in the past, and let me move this over to show you kind of a different method for that, is that every number that you do here, I take this 1, I multiply it by something. I don't know what that something is yet. Technically you do, it's 5. But let's say you didn't. You don't know what that something is yet. You multiply 1 by a number, and then you subtract 2, so you get 3. Same thing with this 2. You take 2, you multiply it by some number, and then you subtract 2, and you get 8. Okay, well 2 times some number minus 2 is 8. What was that original number? Right, that's what we want to figure out. What was that original number? Let's go ahead and figure that out. When I subtracted 2, I got 8, so the original number was 10. I'm going to add 2 to figure out what that was. I subtract 2 to get 3. That means my original number was 5. So I'm going to write that as a 5. Not permanently, just to say I have to multiply 1 by something to get 5. I have to multiply 2 by that same thing to get 10. What is that value? Looks like it's times 5 times 5. Right? You take this number, you multiply it by 5, then you subtract 2, and then you get those numbers 3, 8, etc. So that's another way of figuring out. It's a little longer. It's a heck of a lot longer. It sure is. But when you're doing quadratics, this has to be one of your methods if you're using tables. I will show you another method. I have not taught you it in class before. I will teach you it here if you'd like to take a look. We'll do the same exact thing knowing this portion right here. Y equals m times x minus 2. Remember, we are trying to solve for m. By the way, it looks like this video will go longer than 50 minutes because of this time I want to teach you with it. We need to solve for this. Okay. Because this is linear, this m always stays the same. It never changes. I can use any of these values. Well, I can't use this one because I already used it for -2 here. But I can use the values 1, 3, or 2, 8, and plug them in for x and y right here. Check this out. If I use 1 and 3, if I plug in 3 for y, notice how 3 is a y, and 1 for x, m times 1 is m. I can solve for m. How? Add 2 to both sides. And I get m equals 5. That is really the practical way of doing this, but I want you to think out loud so often too, because when we do quadratics, we're not solving quadratics immediately. So I just want you to know a bunch of different ways. I could have done that excuse me, with 2 and 8 as well. I would still get m equals 5. So there are a lot of ways that you can do this to fill this thing out. It's kind of nice. You can do all those. Okay, part C, if the output number y is -52, what was the input number? So this is very adamant and specific. I am substituting -52 for y. -52 equals 5x minus 2. Notice how we're doing solving for x problems before we do the actual solving for x problems. And trust me, there are 12 solving for x problems. So maybe I get these out of the way right now. Hang on one second. Maybe we get these out of the way right now and I teach you how you do it, and then if there's something that's a little different in those, I'll teach them then. Otherwise, I should breeze right through them. -52 equals 5x minus 2. Let's figure out what our input number was. Basically, in this table, if I extended this just a little more, here somewhere there's a 52. What was this x value right here? So you have to keep adding 5 to get that number. Or, what if we did keep adding 5? Oh, -52, I'm sorry. -52. Anyway, we have to keep subtracting 5. So, or you can just solve for x. So, your 3 rules for solving for an equation, at least for linear equations. Simplify the left side and the right side. They're simplified. Next step, isolate. Get the x term by itself. So this -2 is bothering you. Add 2 to both sides. -52 plus 2 is -50. So 5x equals -50. Then, step 3, divide. Divide by 5 because that's being multiplied by x. So you can figure out what x is supposed to be. That's -10 right there. So when x equals -10, y equals -52 in that rule. Notice how we use this rule to make that happen. Number 116, use guess and check to solve the problem below. Let me read the problem, then I'll explain it. We'll go from there. For the school play, the advance tickets cost $3, and tickets at the door cost $5. 30 more tickets were sold at the door than in advance, and $2,630 were collected. How many tickets were sold at the door? Write your answer in a sentence. Notice the question they're asking. How many tickets were sold at the door? So first of all, make sure you always answer the question that's being asked. Don't just x equals, y equals, this, that. And don't just fill out the table either. You have to write your answer in a sentence. And that's what it says below in yours. Now, on your sheet, it only shows a few entries here. It shows advance tickets, tickets at the door, total amount, and check. Not like a money check, but guess and check. See if you're right or wrong. I added 2 more. The cost of buying an advance ticket. Not really the cost of buying one advance ticket, but how much money that you got from how many were purchased. Because the total is in dollars, right? I don't want to see how many tickets I got for each of these and add them up and get dollars. I need to see how much they cost or how much we got total from it. So I added 2 more columns. Try and fill in. I know you do have space on yours. Try and write in 2 more columns that'll have this, and we can guess and check from there. So the idea of guess and check, and I'm not going to completely restate it because we've done this a whole lot. But the idea of guess and check is that you have to start guessing numbers as a quantity. And after that, all of the other things fall in line based on formulas, right? You choose a number for how many advance tickets were bought. Let's say 15 advance tickets were bought. Keep in mind, I don't know what this answer is yet. Okay, if 15 advance tickets were bought, they cost $3 each. So the advanced tickets, you got to take this guy and you got to multiply it by 3. So 15 times 3 is 45. You get $45 for selling 15 tickets in advance. That's what that means. Tickets at the door. Now you're not going to guess this number because they say that there were 30 more tickets that were sold at the door than there were in advance. So whatever you're going to have for advance tickets, you got to add 30 to that to get tickets at the door. 15 plus 30 also happens to be 45. Only this is in terms of tickets, not dollars. Right? This is $45. The door ticket cost, each door ticket costs $5. So you're going to take 45 and multiply it by 5. Hopefully you have a calculator handy, or you might know this is $225. Your total amount is your dollar cost right here plus your dollar cost right here. So that's going to be $45 plus $25, $225. 45 plus 225 is 270. $270. Is 270 the same thing as 2630? Not even close. So that's how guess and check works. You take something, hang on, I got a water bottle and I am prepared to drink it. A lot of talking. All right. So the way guess and check works is you literally guess. I guessed randomly my first time. I was way off. I was way low compared to 2630. In fact, I was almost 10 times too low. Way too low. So what I'm going to do is I'm going to shoot for a bigger number. My next guess will not be random. It can be way off, but it has some educated guess in it. I know that my first guess was very low, so I will guess very much higher. Let's try 100. Let's try 100. Keep in mind, I don't know what the answer is. Could be way off base, could not be. I'm going to take 100 tickets. They cost $3 each. I made $300 selling 100 tickets. Woohoo! Tickets at the door, I sold 30 more tickets at the door than I sold in advance. So I'm going to add 30, I get 130. 130 is going to be multiplied by 5. That's how much money you'll make selling them at the door. So that would be 650, I think. Correct me if I'm wrong there. Okay, so this is going to be 300 plus 650. That's going to give you 950. Still way, way too low there. Remember, we're doing 2,630. So now I've kind of taken this look and I've said, you know, I've been aiming too low. Let's just shoot the bar higher, right? Let's raise the bar. Let's aim this a little higher because obviously we're not doing enough here. I'm going to look at 200. In fact, that still might be too short. Let's go and look at 250. I'm not sure what it's going to be at, but let's look at 250. Let's start going higher here. Let's aim over this time so we know what we're in between instead of saying where is our ceiling, right? How high does it go? 250 times 3 is $750. Now we talking, all right? 250 plus 30 is 280. 280 times 5, 1,400. I'm still not high enough. Jeez, I'm not aiming high enough. I'm sorry. That's why we play guess and check, though. In fact, I might need more table entries. 750 plus 1,400 is 2,150. Notice, now we're at least in the 2,000s. We're not, like, way off base as we could have been. So that's a no, that's a no, that's a no. Obviously, my guess of 15 should have been higher. I knew I wasn't going to get a big number from that, but that's the point of it. You can guess whatever you want as long as it fits within the realm of what you need to do. Okay, I was in the ballpark this time. So this time I'm going to try 300. I'm going to try a little bit higher. I better get somewhere roundabout this time. 300 times 3 is 900. 300 plus 30 is 330. Oh boy, let's see. Times 5. 1650, I think. Oh, I'm still not high enough. I'm getting closer, though. Man, I am a bad teacher to go off of by saying shoot higher and higher, and I'm not even shooting high enough. Okay, so that's going to be 2550. Very close. Not even ballpark. I'm only $80 away. Okay, so you know it's not around 400 or whatever. I'm going to guess a little higher. Let's go up by tens this time. Let's go, what color haven't I used? I haven't used black. 310. 310 times 3 is 930. Okay, plus 30 here. That's 340. I wonder why this video is taking so long. I can't guess and check right. But hey, that's that's the part. Yeah, that's the point of it. That's the purpose. You're having some fun. Times 5. I know it's going to be 50 more than this one because that's 10 more. 10 times 5 is 50, so that's 1700. Is that right? What was this, 2630? Ooh, I think I got it. Wow, good. So 930 plus 1700. Yep, that's 2630. I swear I did not mean to be that on point, where I would actually get onto the fifth step. The way you'd normally do it is shoot for something significantly higher. Maybe I should have shot for 400 after 100. I shoot for that, and they're like, okay, it's got to be in between. And you keep going. So, answer in a complete sentence. You can't answer something without knowing the question. How many tickets were sold at the door? Not how much did you make selling at the door. Not how many tickets were sold in advance. Not how many were sold total. How many were sold at the door? 340 tickets were sold at the door. That's all you need to say. Now notice how I used units like tickets. It's important. You want to have units to make sure you know how to answer that. Okay, moving on. I want to save time. Okay, here's where they're... Oh, no, these aren't solving equations. Find the x-intercept and y-intercept for the following linear equations by plugging in 0 for one variable and solving for the other one. So they actually tell you what to do. Well, I mean, they're demanding an objective, but they're giving you the way to do it. Plugging in 0 for one variable and solving for the other one. Let's go and talk about that a little bit very quickly. Let's say I make a graph here. Let's say your graph, it looks like that. Okay. There are two key points on this graph that are very distinct. This one here, this one's called the x-intercept. It is the value for x when y equals 0. It is the value for x when it crosses the x-axis, when your graph does. So this value is going to be some x value, comma, 0. Remember, y equals 0 when you're getting your x-intercept. Hang on, quick water break. So what you can do is either, maybe you have the graph and maybe you can eyeball it and say, oh, look, there it is. In fact, we're going to do that a little bit when we look at our graphs later. But sometimes it's not always set in stone. Sometimes your graphs are off. You can also do it mathematically, and that's what we're going to do. We are going to find out what the x and the y-intercept here over here by plugging in 0 for y to solve for x and 0 for x to solve for y. Now the y-intercept, normally, depending on your equation, is significantly easier to find, especially in problem number 1. Actually, only in problem number 1, or problem letter A. The y-intercept is at 0, comma y. It's the value where your graph crosses the y-axis, and it's the value for y when x equals 0. The reason why this works so well on the y-intercept, as you've always known, is it's the same as your starting value. Because you plug in 0 for x, y equals just that number. But let's do it the real way now. Let's do the y-intercept first. You'll get y equals 3 times 0 plus 10. 3 times 0 is 0, so y equals 10. Once again, it's the same as your starting value when you have it in this form, right? You need to have it in the proper form to make that happen. Your x-intercept is normally trickier for a few reasons. Sometimes it's not even a good solid number. In fact, sometimes your y-intercept's not either. But your x-intercept doesn't depend on what y equals. So we're going to set, well, it does. It depends on y equaling 0. But it's not based on your rule equation. Subtracts 10, you'll get 3x is negative 10. You'll get x equals negative 10 over 3. Once again, you'll kind of see that we're doing a lot of equation solving before we get to the equation solving problems. So please forgive me if I rush through those, unless I talk about simplifying, like distributing a negative and stuff. I'm solving for things for you right now, which is good, because then those other 12 problems should come through very quickly. Now, the actual intercepts, if you want to write them out, if they're crossing through, your x-intercept is actually negative 10 thirds, comma 0. and your actual y-intercept is 0, comma, 10. These are actual points on your graph. Like, these actually exist. This is where it crosses through. That's about negative 3.333, whatever. I don't want you to round that number. I want you to leave it as a fraction. It's an exact number if you do that. Okay? All right, B. This one's actually pretty nice too here. This is what's called standard form. It's close to standard form for algebra. Not that that really matters, but 12 is not your starting value. Okay, this is not a y equals equation. You can't just say, oh, it's 12 for y-intercept. You have to be very, very particular and make sure that you substitute 0 for x and 0 for y to solve for your y and x intercepts. What I really like about what's called standard form is that your x's and y's are both on the same side of the equation, so you don't have to do any manipulation of anything else. If you're solving for the y-intercept, notice how I set x equal to 0. Okay, but did I really have to do this step? If x equals 0, won't this just go away anyway? Yeah, this will just go away, and you'll just get 4y equals 12, and then you have to, then you have to divide by 4. You get y equals 3. Okay, but notice what I'm going to do for the x-intercept here. I'm substituting 0 for y. Do I have to write that I'm substituting 0 for y? No, if I'm substituting 0 for y, then 4 times 0 is 0. That would be gone. This is what your x-intercept equation will start to look like. If 3x is negative 12, or negative 3x is 12, I just divide by negative 3, and I get x equals negative 4. Okay, so the actual values are negative 4, 0, and 0, 3, like that. But notice what I did there for that form. I just substituted 0 for y, but the other thing just went away. So that's what I'm going to kind of do with the rest of these as well. I'm just going to make it go away. I do want to speed up time. If you have questions, maybe check out the first one again, because I did do a pretty thorough explanation on that one. Letter C. Let's do x-intercept first this time. X-intercept, substitute 0 for y. Subtract 8. I'll get 3x equals negative 8, divide by 3, x equals negative 8 thirds. Do notice how I did speed that up. If you need to, you can always pause. Please do so. But solving for x, like I said, we're going to have a lot of solving for x equations. So I do, once again, I keep saying I want to speed it up. Of course I do. But I want you to learn it. This isn't because, oh, I'm pressed for time for anything. I just want to make sure that you find this thing useful. 3 times 0 is 0. Notice how I don't even have to write that. Just 2y equals 8. Just go straight into it. And y equals 4. Now, something else I could have done. You know what? I'm gonna not say anything there. We're good. D, last one. Substitute for the x-intercept. Substitute 0 for y. 10 equals 0 minus 2x. Divide by negative 2. You'll get x equals negative 5. Substitute 0 for y, or for x, for the y-intercept. Notice I'm specifically labeling that too. You get 10 equals y minus 2 times 0, which is 0. Hey, 10 equals y. That's it. You don't need to do anything else. You're good to go. Okay, so again, those points, that's negative 5, 0, and 0, 10. These are points on your graph. When we get into graphing, you'll see it. Okay, only 2 more sets of equations. There are 12 of these solving for x, and then there are 6 graphing problems, I do believe. So let's go through these. At least here you get to do more steps, maybe. It says solve for x. Some of these are n. Please solve for n and a and p and m. They're not all x. Step 1 is simplify. Ignore one side of the equation, hide it, cover it, and then look at the other side and make sure both terms are all like terms are combined. Negative 20 can't combine with anything on the left side, but on the left side, negative 4x minus 6x is negative 10x. So I simplified. Step 2 is isolation. Now the x term is isolated. It's by itself. So I'm good to go there. Step 3 is dividing. Divide by negative 10. Negative 20 divided by negative 10 is the same as positive 20 divided by positive 10. And 20 divided by 10 is 2, as is x. You can always double check. I'm not going to spend time doing that, but to do so, substitute 2 for the number that you had and make sure that both sides equal each other. Number 2. Simplify first. Left side is simplified. Right side is not. 1 plus 5. It's not minus 5. This plus 5 goes with that. 1 plus 5 is 6. Then there's a minus 2n. It's not isolated. Step 2, subtract 6 from both sides. You get 0 on this side, negative 2n on this side. This is not a no solution problem. Negative 2 times a number is 0. What is that number? Well, divided by negative 2. 0 divided by negative 2 is 0. N equals 0. That's the only number you can plug into there to make that true. Number 3, step 1, simplify. Check. Check. Step 2, isolate. Bring your x's to one side of the equation. Bring your constants to the other side. I'll do this in 2 different steps. I'll subtract 7x over to the left side, so I have no x's on the right, and just one positive x on the left there. So I have x minus 2 equals negative 9. Let's bring the 2 over. It's negative right now. Let's go ahead and add 2, so you get 0 on the left side. Negative 2 plus 2 is 0. You'll get x equals negative 9 plus 2, which is negative 7, not negative 11. And always, please, if you are not yet confident with how you do these, double check. Plug them back in. Hopefully you have enough time to make that happen while you're taking the test. And number 4, simplify both sides. Left side, check. Right side, check. Number 2, isolate the a variable here. Add 5a to both sides. Notice you can subtract a if you want to. I'm not objecting against that, but it's just that now you have to deal with negative numbers. It's up to you. And I'm going to do this all in one step. Notice how I can do that. It's possible. Subtract 5 from both sides. I want to get constants on one side, variables on the other. Okay, so a plus 5a is 6a. 5 minus 5 is 0. We're getting another one of these. Okay, that's fine. A equals 0. Once again, 6 times the number 0, a has to be 0. Okay, number 5, 4m minus 4 equals m. Step 1, simplify. Check. Step 2, check and check. Step 2, bring your variables to one side, your constants to the other. In this case, I'm going to take this 4m and subtract it here. The only reason is because I already have constants here. I don't want to take 2 steps to do this. I'm just going to take one step, subtract 4m, and then you get this uh-oh moment. 4m minus 4m is 0. That's what we expected. But this also has 4m minus 4m, and that also is 0. So it says negative 4 equals 0. And you go, what? Right? First thing you might say is, did I do the math right? So you go back and check. And you say, yeah, I did the math right. And then you box it, and you're like, okay, I'm done. But you're not done. You are trying to solve the following equations for your variable. Now, I don't know what I can plug in for m yet. Seeing all these, I know what I can plug in to 0, negative 7, and 0. But here, I am clueless. In fact, I don't even know what this statement means, because this statement's not true. So what it really means is that there is no possible solution you could ever plug in. There's no value you could ever plug in and make this true. You will always get a scenario where the left side will not equal the right side. I can't multiply 4 by a number and subtract 4 and get 4 times the original number. Forget this being 4 times the number. Let's just call it x. How can x minus 4 equal x? How can you take a number, subtract 4, and get that same number? Is 6 minus 4 equal 6? Absolutely not. So it's that idea. You can't get that. This is no solution. There are no values for x you can make that work for. And that's what that part means right there. Number 6. Step 1, simplify. Okay, the left side's simplified, but the right side is not. 5p plus 3p is 8p, and then you have a minus 8. Step 2, isolate. Notice why I'm going to subtract the p this time. I don't want to deal with negatives in my variables if I can deal with it. Subtract p and add 8. I'm going to move those over. 8p minus p is 7p. Negative 1 plus 8 is 8 minus 1, which is 7. Divide both sides by 7. You get p equals... Notice how you can cross that out, but 7 over 7 isn't 0, it's 1. So don't cross it out and just think, oh, it's 0. That's for addition and subtraction. P equals 1. Number 7, continuing on. Let's get through these maybe a little more quickly, assuming there's nothing different. Step 1, simplify. Check. Step 2, isolate. Let's add 5p for the same reasons as I did before. Subtract 4. Notice how when I get through this more quickly, I'm going to be doing less steps. I want you to really see that you know how to do this. You don't have to do mental math. But I want you to see what mental math still means when I do that. Negative 18 equals 13p. That doesn't look very handsome as far as a number goes. Divide by 13. Ooh, that doesn't look great. P equals negative 18 over 13. Hey, guess what? That's your answer. I mean, there's nothing wrong with it. Unless I typed this problem wrong because I typed these over. Nothing wrong with that answer. That's still a number. Still works. Plug it in. Should still be able to work. Okay, notice how this time I'm actually not going... Well, actually I should, because this gives you another no solution. Notice how I'm going to subtract p from both sides here. They cancel, and you get negative 4 equals negative 9. Same as last time. No solution. This cannot happen. So that's no... Whoops. Excuse me. Solution. Okay, number 9. Here's where I do have to slow it down as far as the first step goes, which is still simplifying. Simplifying isn't just about combining like terms. It's about doing whatever you need to make this problem more accessible. And there are parentheses here, and I want to get rid of them. So negative 8's on the left side, but on the right side here, I have to distribute the negative. I am subtracting this entire quantity, which means I'm subtracting everything inside. That's minus a positive x minus a positive 4. Now it's simplified. I didn't combine anything, but now I can do things because I can treat them for the sign that they actually are. This is actually a negative x and actually a negative 4. Here we go. All negative numbers. Let's go ahead and let's add 4 to both sides. You're going to come up with something that's a little more unique here. This is still a negative x, remember. Negative x equals negative 4. What's the number that I make negative to get negative 4? Well, it's 4. Right? If negative x is negative 4, then x equals 4. Another way to look at it is this is negative 1 times x equals negative 4. So I can really just divide both sides by negative 1. Negative 1 over negative 1 is 1, positive 1. And negative 4 over negative 1 is positive 4. So you get x equals 4. Okay, same thing as last time, only this time there's some actual distribution involved. I have to take the negative 4 and multiply it by the negative 6 and by the negative 3. I'll go and do this one step at a time. Negative 4 times negative 6x. And then I'm going to put the plus there only because I'm putting the negative right here so you don't forget that you have to... That's not a 13. So you don't forget to actually do negative times negative here. 12 equals positive 24x. That's negative 4 times 6x. Plus negative 4 times negative 3 is positive 12. Subtract 12 from both sides. This is one of those examples where I'm not going to write that. 12 minus 12 is 0. You get 24 times x equals 0. And just like all those other weird ones you had before, x also equals 0. Number 11. 14 equals the opposite of p minus 8. The opposite of p minus 8 is negative p plus 8 for the same reason. Switch the signs inside. And if you really have trouble with that, if you're wondering what to do, notice this is the same thing as negative 1. I could have distributed a negative 1 times p plus a negative 1 times negative 8, and it'll be the same thing like how I did here, and it'll get me negative p plus 8. You can do that as well. Negative p, I'm going to subtract 8. Let's go ahead and do this one this time. Equals, what is that, 6? If the opposite of p is 6, you can divide by negative 1, but I want you to notice that this p would have to be negative 6. Because the opposite of negative 6 is 6. That's the number you plug in for p to get 6. And there's your answer. Finally, number 12. Nothing much different out of the ordinary here. Negative 7 plus 4x. If you still have trouble with that, please rewind to the first time I did it on number 9 over... No, was it number 9? Yeah, number 9 over here. Add 7. Boom, 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 boom. 4x equals 9 plus 7 is 16. Divide by 4. X equals 4. So some of these problems weren't necessarily too complex or anything. They were pretty good. And I gave you 12 solving equations problems plus a few before that. I gave you a whole lot. Okay, graph the following equations. 1 second. Get some more water. This video is brought to you by Dasani. Purified water enhanced with minerals for a pure, fresh taste. Dasani. Okay, let's go ahead and do some graphing here. Number 1. Now, I'm going to color code this the same color as this thing is. And as you can notice, I made a pretty rainbow. The reason is because you have 6 different graphs. I want to just fit this on one graph here. And actually, before I do that, let's go ahead and do some things that I ask you to do when you graph, which is labeling and scaling. Label, x-axis, y-axis. Scale, 1, 2, 3, 4. I'm going to make every 5 be 5, which makes sense. That means every 1 is also 1. I don't want to write all those, though. That would sure clutter this thing up. Okay, let's start with number 1 here. This is y equals negative 2x minus 4. Let's make sure we're red. Before we start, let me write this out. Y equals mx plus b. The important thing is if you are going to graph without using a table, you need to know what these things mean. We talked about them. M means slope. B means y-intercept. But what they really truly mean, slope is rise over run. We've talked about that. You have to understand that if something is written not as a fraction, you can still express it as a fraction. So that's what I'm going to clarify with first. The next thing I'll talk about is that, well, you know what? It rises and runs and does all that stuff. That's awesome. But where did it start at? Right? And you can make stories out of these things too if you absolutely need to. Okay? I always do pizza stories and things like that. I can do that. That's fine. But you really need to know what that means. So the y-intercept is the value. It'll look like this on a graph. It'll be 0, comma, that b, whatever the value is. So in doing y equals negative 2x plus 4, I'll go ahead and just do this one first with that information up there. I'm going to start at the point 0, 4. Notice the reason is because this is my starting value. Where do I start? Right there. Perfect. Now, my slope is the kind of harder part, but make sure you stay tuned with this. Negative 2 is also negative 2 over 1. I'm writing this because I want you to make sure you understand the rise over your run, and that my rise is negative as my run is positive. So as I go over 1, this way, this way, this way, this way, I'm going to fall 2 each time. If rise is positive, then fall is negative. So I will go down 2 from this original point. I'll go down 1, 2, as I run 1. This is another point that's on your graph. Don't take my word for it. Go ahead and plug in 1 into this thing, into this original equation right here. Negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. So your point right here is negative 1, 2. That fits. And all the rest will fit, and this should be a linear equation, a straight line. From this point, I can also go down 1, 2, and over 2, and so on and so forth. And I will actually speed this up for the sake of time, especially if you do know what to do, or especially if you don't care about what to do here. But the rest of the stuff is graphing, and make sure you tune in for the equal values method if you are going to be here for that. Final thing, make sure you have that straight edge. I'll go ahead and put these lines right here and go straight through. Boom. And there's what your graph should pretty much look like. That is the red one right here. Now, if you have to graph with more than one thing, if you have to plot more than one line on a graph, make sure you have some sort of labeling. My labeling is this is red, this is red. They're both the same thing. That's why I'm going to make this next one orange. Number 2, y equals 3 over 1 x minus 1. I'm starting at 0, comma, negative 1. I'm going to start at negative 1. And I'm going to rise 3, run 1. So I'm going to go up 3 over 1. Notice it's hitting the same point as this other one. Up 3 over 1. Up 3 over 1. What I didn't tell you about was how I did these other points over here. So I'm going to talk about it with this one right here. If this rises 3 and runs every 1, then something else ran 1 and rose 3 as well over here. Or another way to put it is you could also say, if I rise 3 every time I run up 1, I can also go down 3 and go 1 to the left. Notice how negative 3 divided by negative 1 still gives you 3. It still gives me that slope. The fact that I went down doesn't change the fact because I'm going to the left. So you always want to think that run is positive. when you're talking about how much you're rising or falling. That way you know that you're consistent with it. And in fact, that's what they mean. Because when they do word problems, they normally talk about time and time really seems to be the big one. But supplies, you have a certain quantity as you're doing it. So, make sure that you're well aware of that fact. Whoops. Need to get my marker. I erased my 5. Silly me. There it goes. Let's go ahead and graph this guy right here. Just do as many points as you can. I think it's most beneficial to you if you do. And the lines cross through about right there. Not perfect. Close to perfect. Good for me. There should be arrows. There is an arrow on the top. It just my thing ran out of room. Okay, yellow. I hope you can see this one. Y equals x minus 3. Now, x is 1 over 1. 1x, 1 over 1. So I rise 1, I run 1. I rise 1, I run 1. So I start at negative 3. Yeah, it's not a very good looking yellow. I go up 1 over 1. Up 1 over 1. Up 1 over 1. Etc., etc., etc. I also go down 1 into the left one. Down 1 into the left one. Notice how, again, you should be graphing this on different graphs. Probably. I'm just doing this all on one. You'll see a good reason why once I kind of get it all sorted out here. Okay, there's yellow. Green. Green. Y equals negative 1/2 x minus 3. You're like, uh-oh, fraction. But you know what? All of these really are fractions, aren't they? This was negative 2 over 1. This was 3 over 1. This is 1 over 1. This is just negative 1 over 2. It's not going to bite. Negative 1 over 2x. Let me just go to the starting point, and then I'll show you what to do here. Okay, it's also at negative 3. Check this out. This is just rise over run. Fractions for slope don't hurt. In fact, if you write them all as fractions, you'll really benefit from it. The only thing is make sure you know that it's negative. I will fall 1 and go over 1, 2. Down 1 over 2. That's what that negative 1 over 2 means. Down 1 over 2. Down 1 over 2, etc. Say that in your head as you do this. You'll really connect the dots. No pun intended. I really didn't think about that as I said that. You will really put 2 and 2 together when you solve for all these. So here goes your line. Queen, just like that. It's probably the least perfect of all of them. And 2 more. See if you can recognize what this one is. This is negative 1, which is negative 1 over 1. So, when I start at 5, when I start way up here, I will go down 1 over 1. Down 1 this way, 1 to the right. Okay, one thing you might have noticed, and I haven't pointed out right here, is that negative slopes go downward as you go to the right. Positive slopes go upward as you go to the right. And a slope of 0, which is the next one we're about to see, is flat horizontal. And this thing looks a little bit like that. There's your graph there. And final one, purple. Purple. I'm so sorry. Y equals negative 4. And you're like, wait a second, what is that? What if I wrote y equals mx plus b, this equation? Does this negative 4 have an x tied to it? No. So this must be your constant, your starting value, which means, where's your mx? Where is that guy? I see minus 4 right here. What times x makes this go away? 0, right? If this is 0, then, you can call it 0 over 1 if you want. That's the same thing. The idea is we're going to start at negative 4. We are going to rise or fall nothing. We won't rise or fall. 0 over 1. 0 over 1. Up or down 0 over 1, etc. And notice, this is a straight, flat, horizontal line. So a slope of 0 gives you that whole flatness right there all the way across at negative 4. The reason is because y equals negative 4. No matter what x equals, even if you did a table, no matter what you plug in for x, because right there, you'll get negative 4 for y all the way through. Okay? And those are your 6 graphs, and that's all you need to fill out. But I'm going to do one more thing, and that's with respect to these graphs. I want you to see what the equal values method is, because that's a big part of your test in the sense that it's something that you actually learned, and I need you to make sure that you can associate it. I'm erasing all those dots and cleaning this up just a little bit here. Actually, I want to put those 5s back. 5, 5, 1, 2, 3. Whoops, wrong place. Z, hello. -5 and -5. Okay, equal values method. All the equal values method says is that you might have multiple equations. In fact, I have multiple. That you might have a lot of equations. Even I think you're only going to have 2 on a test. And we want to find technically their point of intersection. Notice how in some of these graphs, I believe this one crosses at the same place. In some of these graphs, I have actual points of intersection. Okay. Some of them do not cross at integers, and I'm not going to really look at those ones, but I will stress why it's important to say that, hey, you don't always want to just look at a graph, especially if you don't graph very well. We can use the equations to solve for what these xy values are. For example, let's do one that we know for sure has the same xy value, like this one over here. It's not so obtrusive. This point is 1, 2, 3, 4, comma 1. The yellow and the blue equation both intersect at the point 4, 1. What that means is, if I take this yellow equation and this blue equation, I want to find the point where this system of equations have the same x value and the same y value. You have to remember, this point 4, 1, although I guess you already know the answer before knowing the answer, but if I plug in 4 for x and 1 for y, I will get a true statement for both equations. Meanwhile, if I plug in this point up here, whatever it is, it'll only work for the yellow equation. It won't work for the blue equation because it's not on the blue line. The line is nothing more than a set of points. So what I want to do for equal values method is if the y's are truly equal to each other, I want to set y equal to y. That means if y equals x minus 3, y equals negative x plus 5, and y equals y, then these two have to equal each other. So that's the whole idea. We're going to substitute x minus 3 for y on one side of the equation, and we're going to substitute negative x plus 5 on the other side of the equation. And you will solve for x. And when you solve for x, you can use either equation to solve for y, and you will find the coordinate point where these two intersect. I'm only going to do this maybe 4 times total because I'm sure this is running over an hour. And I did say I was going to make it shorter. Too bad. Add x to both sides. I'm going to save time by doing the equations a little more quickly. Add 3 to both sides. 2x equals 8 divided by 2, x equals 4. Now, you're not done. The whole point is to find the point of intersection. We have 4 comma something. I need to find out what that something is. Well, you can take that 4 and you can insert it into this equation. Or you can take that 4 and insert it into this equation. Because the thing is, and I'm only going to do this once for both equations, y equals 4 minus 3, which is 1. That was the top equation. The bottom equation, you can do it for either equation because you are finding when these values equal each other. Negative 4 plus 5 is 1. Notice how they both equaled the same thing because at this point, 4, 1, yellow and blue both intersect. That is what the equal values method is all about. Finding when these 2 points of intersection are the exact same. So notice how 4, 1 applied by using equations by setting them equal to each other. Now this doesn't work unless you have y equals on one side of the equation because you must substitute. You must substitute to solve for the same y's and the same x's. Okay, let's do it again with another set. I'll only do it 2 more times. I'll do it with one for a good reason why you'd want to do it, and it's for one when they don't land on integers. Let's take a look at, for example, let's see which one doesn't. Okay, I think those intersect. I don't think these two do. Check these two out. I don't think these two cross at some very nice looking point. Well, they might. Let's see. Like, you know how I graph weird and whatever else, I might not know what this is. I have no idea what this point is. It's around negative 1 or negative 0.5 comma something, but I don't know for sure. But what I do know this is this is the orange and the green equations. Y equals 3x minus 1 and y equals negative 1/2. Ooh, I don't know. I did that. Negative 1/2 x minus 3. Hey, you have to deal with fractions every so often. You might as well see it when I teach you it. Set 3x minus 1 equal to negative 1/2 x minus 3. Okay. I'm going to start small. I'm going to add 1 to both sides to start isolating my x a little bit. Add 1, negative 3 plus 1 is negative 2. Okay, I have to add 1/2 x. Maybe you're a guy who likes to use decimals, and maybe it's an exact decimal number, or you want to put 3.5. Okay, I'd rather use a decimal. I'm going to add 1/2 x, which is 0.5x, so I get 3.5x equals negative 2. Here's the problem dividing by this. I don't want you to leave this as a fraction. Whoops. And write negative 2 over 3.5. You have to have it in terms of, you can't have a decimal inside a fraction. That defeats the purpose of a fraction. So I want you to practice common denominators. We're going to add 1/2 x. And add 1/2 x. Okay, I'm going to write this on the side. 3 plus 1/2 is what we're doing. 3 is 3 over 1. We have to find a common denominator. Multiply top and bottom by 2, and you will get a common denominator. You'll get 6 over 2. 6 over 2 plus 1 over 2 equals 7 over 2. So this now is 7 over 2x equals negative 2. How the heck do you solve for that? Well, one way is to divide both sides by 7 over 2. Right? That's what we're doing anyway. Divide by 7 over 2. Now, 7 over 2 divided by 7 over 2 is 1. But what's negative 2 divided by 7 over 2? Well, negative 2 is negative 2 over 1. Dividing by a fraction is the same as multiplying by its reciprocal. Dividing by 7 over 2 is multiplying by 2 over 7. So x equals negative 4 over 7. Geez, that was very hard to do, but you can see why we had to do it that way if you're given a problem. That would be like an extra credit challenge problem. I'm not saying you can't do it. I'm saying you really have to persevere. You really have to say, I can do it. I'm going to try it. I know fractions. I know these steps. I'm not going to let it I'm not going to let it frustrate me. So you see how it's kind of negative 4 over 7 right there? I kind of see it. Obviously, I'm running this video longer than I should be for your sake, but let's make it happen anyway. Now to solve for this is where it gets kind of tricky because you have to solve for y still, and you have to use a fraction. I'm going to plug in negative 4 over 7 for one of these equations. Doesn't matter which. Let's go ahead and plug into the bottom one. I want you to get used to using fractions with fractions. Negative 1/2 times negative 4 over 7. Notice how I'm plugging in negative 4 over 7 for x minus 3. So y equals positive 4 over 14 minus, no x. Positive 4 over 4, whoops. Minus 3. 4 over 14 can actually reduce. That can reduce to 2 over 7. Okay, 3 minus 3 over 1, multiply top and bottom by 7. That'll get you a common denominator of 7. That's minus 21 over 7. 2 minus 21 is negative 19. So notice, negative 19 over 7. Notice, you would never get that. Even I wouldn't. You would never get that number by just looking at the point of intersection. I would have no idea what that is. I'd say, oh, it's close to, close to that. Close to negative 3 and you know and stuff. But no, you would not know that your solution by looking at a graph is that. And that's the importance of using the equal values method, even if it's a little difficult. That's your exact answer to where those two things intersect. And you can see why, you can see why I'm helping you solve for practice problems here, so you get a different look at it. I'm only going to give you one more, and then you're done. And some people might have hung up. What's the phrase? Hung the towel. Thrown in the towel. Some of you guys might have already thrown in the towel already. That's fine. That's up to you. You can stop this video whenever you say, "Okay, Mr. Robinson, I'm ready." The only reason I'm doing this last one is because I'm looking at 3 of them, purple, orange, and yellow, that look like they all intersect at the same place. And I want to show you that you can do this multiple different ways and make it happen. So you see this one right here? I think they all intersect at the same place here. So you have y equals negative 4. That one's a dead giveaway. They tell you, look, y equals negative 4. You already know what to do with that one. Y equals x minus 3. And y equals... orange, 3x minus 1. So what you could do is equal values method with any of these. But look, we already know y equals 4. I mean, you could save yourself time. You could say, oh, I already know this is something comma negative 4. But if you didn't know that, let's use equal values method with the tough ones first. X minus 3 equals 3x minus 1. Okay? Solving for x, I'm going to subtract. Hang on. Here, this time I'll add 3 and subtract 3x. Okay? So we get x minus 3x is negative 2x. Negative 1 plus 3 is 2. Divide by negative 2, x equals negative 1. When you plug in negative 1 into one of these equations, any of these three, let's try the top one. Y equals negative 1 minus 3. That equals negative 4. Does that work? Yeah, well, look, we're supposed to get negative 4. So negative 1, negative 4 is your answer. We can tell it's supposed to be negative 1, negative 4, but that's just but one way to do it. You could do it two more ways. I can use equal values method on this equation and this equation. Notice if y equals negative 4, I just got to plug in negative 4 right there. Negative 4 equals x minus 3. Add 3. X equals negative 1. Notice how excited I'm getting over this. And we already know that y equals negative 4 because that was your other equation. Finally, I could plug in negative 4 into this equation as well. Negative 4 equals 3x minus 1. Add 1. 3x equals negative 3. Divide by 3, x equals negative 1. So you can see, you can use any equation for this one. All of these intersect. Just use equal values method. Solve for y and then plug these things in, and you're good to go. Now, that was not on your worksheet. You can make it on your worksheet if you'd like to. You can write it in your notes. Remember, you have a study guide on the front of this thing. You can use it for the test if you filled this whole thing out. And hopefully you filled it out while you watched it, so you're given that ticket. But I want you to write some of these things down and make sure you totally know how that works, especially the equal values method, because we learned it so late. Okay, I know that I ran over an hour for sure, but hopefully it's of good use to you. And please ask questions. Notice how much we did here, quite a bit. It's all in good, it's all in good fun. I want to help you out, make sure you can get these things right. All right, have a good night and good luck on your test.